And so now you have this really rich record of everything in the PR that's associated with that PR. And it's
Yeah.
getting closer to proper software engineering practices where you have like the test that's like automatically conducted from the PR itself, and you have all the documentation there.
You're listening to Gradient Dissent, a show where we learn about making machine learning models work in the real world. I'm your host, Lucas Bewell. I love talking to Hamel Husain because he likes making tools for machine learning practitioners the same way I do. He's currently working at GitHub, but before that, he's built large data science teams at Airbnb, DataRobot, and a whole bunch of other really successful companies. I can't wait to talk to him. So Hamel, thanks so much for taking the time to talk today. You're one of the first guests that we've had that I've actually worked with before. So we have a lot to talk about. And I thought, the cool thing that we worked on, which I'd just love for you to describe, is the CodeSearchNet project that you spearheaded. Can you just describe for someone who doesn't know what it is, like what it is and what the goals are?
Yeah. So GitHub has a large corpus of code, as you might imagine. There's all these open source repositories and many different languages. And in the machine learning community, natural language processing is a really exciting space, especially with deep learning. And there's there's a few data sets that people really like for that. But one that sort of hasn't been paid attention to much is perhaps the large corpus of GitHub data. And the thing is, like, that data is already open. It's already open source, but the barrier to entry is kind of high, especially when you're talking about code. To tokenize code or parse code is very complicated, especially when I strip out comments or do something like that. So internally at GitHub, we had a project where we wanted to explore representation learning of code, and kind of explore the possibilities to see if we could learn a representation of code.
And what do you mean by like a representation of the code? Like some abstract representation, or how do you think about that?
Oh yeah, sorry. I mean it in a very canonical machine learning sense, like a learning and embedding of
I
code.
see.
So that aligns with natural language. That was one of the experiments that we wanted to try, to then see if we could use that to boost search results. So someone types in a query. A lot of people don't like GitHub search, understandably. And if you're trying to search for code, you have to, right now it's keyword search. So you have to have a good idea of what the syntax is or what keywords may be in the code that you're trying to find. But what if you don't know that? What if you're trying to search for some kind of concept in a code? Is that possible? And so we started exploring that to see if it would be possible, perhaps, to use machine learning to learn some, an embedding of code to then, do some kind of semantic search. So one of the interesting parts about that is you might wonder, how would you go about doing that? How would you go about learning some embeddings of code? And so kind of stealing a lot of ideas from natural language processing, so it's useful in natural language processing if you have parallel corpus of, let's say one language to another language, like a language translation. So we thought about that and said, that's interesting. I wonder if we could do that with code, since there is a lot of natural language. It happens to be inside code, and specifically comments of code, where people naturally are sort of labeling what code does. And so now this is a tough problem because, comments can be everywhere. They're not necessarily in the same place. They're not necessarily at the same level of granularity or in the same format. And so what we did is we kind of scoped down the problem to methods and functions in various languages, and looked at sort of the doc strings, or what is equivalent to a doc string in Python, which is some comment that documents what that function is doing. So we constructed a large parallel corpus of all of these things, and we did some experimentation, and it was a really exciting project. it kind of we had to kind of stop in the middle for various reasons, as sometimes happens with machine learning projects that are ambitious like this. But in doing so, we thought we should open source the data, and we should kind of present the results we have and give it to the community so they can take it forward from there. So the CodeSearchNet challenge is a large corpus, this large parallel corpus of code in natural language, and it's benchmarks of our attempt at doing information retrieval. So given a query of some kind, can you identify the piece of code that goes with that? So in this case, if given a doc string, can you find the code that is paired with that originally? So the benchmark is an information retrieval task. Mm-hmm. And so we thought, okay, even though we're pausing on this for a moment, we know that everybody is interested in this. Not everybody, but a lot of people may be interested in this. We saw people at various research labs kind of exploring similar problems. So we thought, okay, we should get in the mix being GitHub. And so that was like kind of the impetus to release this data set. And of course, we had a wonderful partnership with Weights and Biases, who hosts the benchmark.
I've heard of them.
yeah. Who hosts the benchmarks, the leaderboard of the different submissions that people have and improvements to the model. And the thing that I really like about Weights and Biases is the transparency. So like, in Kaggle competitions, you only really get to see what is behind the scenes if the author chooses to release the code. But Weights and Biases, you can see all kinds of detail. It's very transparent. And you get very rich logs of what happened during the training process. So that's really helpful. And I think the whole community can see that. And I think that helps drive that forward.
And so just to clarify, so the challenge is, right, it's to sort of find the code that best matches the doc string?
Yeah, so there's a couple of different tasks. So there's one task. So matching a doc string to code is sort of a proxy for what. So like a search query may not look like a doc string. Probably doesn't.
Totally.
And so that task is pairing the doc string with the original code is a proxy for search. So we also have some actual search queries that people have done against Bing. Since we're in Microsoft, we could pull that. We have some ways of finding out like what page they landed on, and if that was kind of infer if that was the thing they were looking for. And so we have another test set that is actual queries from a search engine. Even that is not perfect because the task that we would want is like to simulate is a more scoped search of code, not a global search like on Google or Bing of how to do something. I think that's a solved problem. That works really well, at least for me. So I would say the task isn't perfect, but we sort of did whatever we could in the time we had. And
I think it's awesome that you released the data, but the idea is, I mean, since we work together, I think I kind of understand it, right? It's like, I search for like some algorithm, maybe like, like, I don't know, like insertion sort. And then I map that to code that actually does insertion sort. So maybe there's some embedding space that's like the sort of embedding of insertion sort, right?
Yeah, absolutely. Like if the code doesn't contain the word insertion or sort, you can still find that code.
Because it does
the magic. Yeah, because it does that, yeah.
Yeah.
And that's the idea, is to enhance discoverability of code, to do various things. So
it's super cool. We'll put a link to some materials so folks can find that are more interested.
Hi, we'd love to take a moment to tell you guys about Weights and Biases. Weights and Biases is a tool that helps you track and visualize every detail of your machine learning models. We help you debug your machine learning models in real time, collaborate easily, and advance the state of the art in machine learning. You can integrate Weights and Biases into your models with just a few lines of code. With hyperparameter sweeps, you can find the best set of hyperparameters for your models automatically. You can also track and compare how many GPU resources your models are using. With one line of code, you can visualize model predictions in form of images, videos, audio, plotly charts, molecular data, segmentation maps, and 3D point clouds. You can save everything you need to reproduce your models days, weeks, or even months after training. Finally, with reports, you can make your models come alive. Reports are like blog posts in which your readers can interact with your model metrics and predictions. Reports serve as a centralized repository of metrics, predictions, hyperparameter stride, and accompanying nodes. All of this together gives you a bird's eye view of your machine learning workflow. You can use reports to share your model insights, keep your team on the same page, and collaborate effectively remotely. I'll leave a link in the show notes below to help you get started. And now, let's get back to the episode.
So we actually haven't talked about this, but I was kind of looking at your background and I was seeing that, you worked at DataRobot and you wrote about AutoML. This is another question we get all the time. What do you sort of think is the state of AutoML? Is it something you use in practice? Would you recommend it to people? When is it useful? When is it not useful? What do you think at this point?
I think AutoML is really misunderstood a lot of times.
Maybe define it first, because we might be talking about different things.
And so I think we're talking about the same thing, but I'll define it just for clarity. So I would say AutoML are tools that help you sort of automate your machine learning pipeline as much as possible. And that can mean various different things. And obviously, that definition has a very large scope. I mean, of course, you can automate some parts of your machine learning pipeline. You can try to automate the whole machine learning pipeline. What part are you automating exactly?
Totally.
That kind of gets into the weeds, but I would say something that sufficiently automates a lot of it. You can kind of bucket that into AutoML, but even that is, I don't know if there's an official. There's a organization that has a definition. I don't remember at the top of my head, but that's the way I would define it personally. Mm-hmm. So you're right. I did work at DataRobot, who is a company that has a piece of software, software as a service, and they're one of the first kind of folks to really kind of put AutoML out there. I would say before DataRobot, tools that you may have seen are I think it was called Weka or Weka, and then maybe RapidMiner was one that was popular. Things that sort of automate the machine learning pipeline. Mm-hmm. So kind of to drill in a little bit more, what DataRobot does is, you feed it a prepared set of data. And so you've already done tons of work before getting to this process.
Right.
And you have a target variable and all these features. And so what DataRobot does is it tries a lot of feature engineering steps, kind of almost problem agnostic feature engineering steps. And it tries many different algorithms, all from open source, and it benchmarks them against each other. And it does lots of diagnostics, an incredible amount of diagnostics on your data. And then kind of gives you a leaderboard of all these different models. Again, they're all open, from open source. Mm-hmm. And that's one flavor of that. There's other people that do this. So H2O has a product where I think they call it AutoML, and or self-driving ML or something like that. I don't know what it's exactly, but they do something like this. Mm-hmm. And so the reason why AutoML is misunderstood is people think of it in a certain, kind of put it in a box, and they say, this can't replace a data scientist. Or the objection is, why would I can beat this thing. I have domain knowledge. Why would I want to use an AutoML system when, I can build a model with my domain understanding, kind of to fit the needs better. Like, why would someone want to use AutoML? And so that's the common misunderstanding. And so I wrote about this when I was at Airbnb, the blog you're referencing. And I think the way that it's used most effectively is to really augment a data scientist. You might not use any of the models produced from the AutoML system, which kind of sounds ironic. But really, the AutoML system gives you a lot of information at the very beginning. So I think it's really important to have a baseline. And the better your baseline, like the better off you are. And so you can use AutoML system to give you a pretty competitive baseline to begin with. And the reason like a lot of people use, linear regression or something, or some simple model, or just the average as, baseline or whatever it might be, is, that's easy to do, and you need a baseline to compare what's going on. So that's helpful. And then also you get a lot of diagnostics. You get a lot of things, something that automatically explores your data set, and you can read. You're just getting more information about the task at hand. And if you do that, you can use that information really effectively to go and build your own custom model, and kind of start with some more hypotheses about what might work or what might not work, or invalidate some hypotheses. I mean, it's not uncommon to hear. I hear this all the time. Data scientists will say, you know what, random forests, they don't really work on this model or on this data set, or whatever, neural nets, they don't work. But what if the AutoML system has much better results than you did and uses that model? That's really interesting. Like, why did that happen? That happens like fair number of times. Like when I was at Airbnb, which is has a lot of talented people, it was really interesting. Like sometimes the AutoML system would give you some result that was kind of something you didn't expect. And so I think that it's just really interesting. It's a way of using AutoML, and I don't really see AutoML replacing data scientists, but I see it's like an incredibly useful tool. I mean, just even in doing lots of exploratory data analysis. I know that sounds trivial or easy, but just to have something that does that really nicely for you and gives you all kinds of statistics and metrics and like all kinds of graphs just for free is just a head start. So that's kind of my spiel on AutoML.
It's kind of interesting. Do you make a distinction between AutoML and hyperparameter optimization?
I think hyperparameter optimization is part of AutoML. Like if something is really AutoML, it should also be doing hyperparameter optimization, and that's what a lot of these AutoML frameworks do. And so yeah, I mean, but I wouldn't say hyperparameter tuning on its own is what I would just call AutoML. I mean, this word AutoML is, like I said, very hard to define. You can probably, but it's definitely something that should be included in there.
But what extra stuff does it do? Like try different algorithms, you mean, or what does it do on top of that?
Yeah, so a lot of the magic of, let's say, for example, DataRobot, because I'm really familiar with that product. It does a lot of feature engineering. So it's built by people that are grandmasters at Kaggle. They have 3 or 4, or actually more former grandmasters, and then a lot more people like close to that. And they've taken like all their experience of winning these competitions and sort of like put a lot of recipes in there. So things like, okay, if you're using a tree-based model, here's some feature engineering steps to try. If your data contains text, let's try these feature engineering steps. If your data if your data looks like this, let's try something else. It's like kind of like a lot of these rules built in, but also it's a lot of different recipes. Includes things like model stacking, model ensembling models. It includes hyperparameter tuning, and it's an incredible amount of diagnostics. So you get kind of like feature importance type of stuff in many different ways. You get sort of a lot of model explainability stuff. And And so all that information is pretty useful, regardless of what model you're going to go with, to kind of understand something really fast. And so
That's
yeah,
kind of interesting because I feel like a lot of people think of AutoML as like a way to just sort of get the best model. And yeah, it's funny. I sort of tell people that I also share your view that it's a good way to do exploration, or at least like hyperparameter search. I think is a great way to sort of understand the domain you're in. But I guess, maybe it's because Google has that AutoML product where you actually don't get a lot of data. I think you just get the best model out of it. That sometimes I think of AutoML specifically as just a way to find the best model. But of course, if you get to see all the different runs and how they did, that would be like incredibly useful to learn about your data set.
Yeah, I agree. And yeah, some products, I think they actually kind of think of, maybe they've designed it in such a way where they think of it as a black box and just give you the best model. I don't really think that's that incredibly useful.
Why isn't that useful though? I mean, because I think a lot of from like a business owner's perspective, they might be like, awesome, like it's a pain in the ass to make models. Let me just get done with this.
Well, I would say it is still useful. I agree with you, but it's not as useful. I mean, I would say being able to see everything and learn from it is kind of a lot of value added, and it you can still build it and not look at it, all that stuff if you want to. But I find it to be useful as a data scientist. I've found that makes me like a lot better, and kind of helps to check some stuff that.
When you were working at DataRobot, do you think most teams are using DataRobot more for an exploratory use case or for like an optimization purpose?
It was pretty mixed. So I worked with a lot of customers there, and people were using it to so a lot of people already had a model in production of some kind, and they just wanted to. And that was a really excellent use case. I mean, they just plug that data in DataRobot and see what's going on. And that was a really popular use case. Another one was, okay, you don't know how to get started. You're kind of taking a long time to build a model. You want to use this, and people use that. A lot of people actually use the product to help learn about data science, like because it was so transparent. They could see like all the steps, what you did, and they would learn about like kind of like the workflow. But yeah, I think there was a mix between sort of taking something you already have, putting it there, and exploring. I would say people that already had data scientists, like experienced ones, they found it really useful to get new ideas that like they didn't consider before.
Makes sense. All right, so Hamel, so what are you working on now? What's your day like? Can I guess? I'm just following your Twitter. I haven't talked to you in a while. It seems like you were really into GitHub Actions that I don't totally understand, but I want to learn.
Oh yeah, that's a great question. I guess I am. I mean, I didn't try to be, but it kind of just worked out that way. So you're absolutely right. Kind of become the GitHub Actions person for data science by accident, I think. So yeah, to answer your question, I'm really interested in tools that can help data scientists and building those. That's why I like talking to you so much, because you're also interested in that.
Totally.
And so some of the things, so I mean, that's what, kind of what I was doing, or why I was interested in working at DataRobot. And I did a lot of that at Airbnb. And then at GitHub, I'm doing that also. And so one of the things that I've tried to do is to find ways kind of in the short term. There's some long-term things I'm working on, which, we're exploring, but kind of in the short term, like what can I do right now with the products that GitHub already has to make data science easier. And so it's being creative and trying to figure out what I can provide. So like, there's a couple of examples of that. One is CI/CD, continuous integration delivery for machine learning workflows. So GitHub launched Actions, as you alluded to, and so when I saw that launch, I realized that there's an opportunity to construct a CI/CD sort of plugins that will allow people to have machine learning workflows that kind of that have CI/CD workflows for machine learning.
Could you just because I think a lot of people might not know, including kind of myself, what is a GitHub action and why is it useful for this?
Yeah, that's a good question. So GitHub action, on the surface, GitHub actions look like another CI/CD system like Travis or Circle CI or something like that. Compute that you can run triggered by some GitHub event.
And this runs on GitHub?
Yeah, this runs on GitHub. So, but the way that it's differentiated is in a couple of ways. One is, so you can fire a GitHub action to run on any event, almost any event. So an event means opening an issue, commenting on an issue, opening a PR, labeling a PR. Just think of like almost anything that happens on GitHub, you can trigger actions to run arbitrary code based on that event. And then the reason why actions is special is for like two primary reasons. One is all the metadata associated with like the event that triggered the action is hydrated into the actions environment. So like if you want to know who commented on that PR or whatever, that's super easy to do because it's available inside the environment. Secondly, is let's say like you create a workflow that is super useful. Something like, I'm going to run machine learning workflow, log my metrics to weights and biases, and then you report the metrics back into the PR in GitHub. So that's pretty useful. And so if you want to, you can kind of package it up a little bit, and you can say, okay, I have this workflow. It expects this input, like it expects a run ID, and as an output, it will comment on the issue with this formatted table or something like that. I'm simplifying it, but really, I mean, there's a real we can talk about that, and then I can just use your workflow. I don't have to know anything about how you did that. I can just say, hey, this workflow is pretty cool. I just have to feed it a run ID and some then it will do the same thing on my repo. So I can just reference your kind of packaged workflow from your repo. I don't have to install anything or do anything, and I can compose many different workflows together that do very modular things.
Sorry, dumb question. So how would I pass in the run ID? Like where would that happen?
Yeah. So with every step in an actions workflow, if you're using a packaged action, that you can there's inputs. So you can say, so that inputs can come from anywhere. You can hard code a string, or you can say that input can come from another step in the workflow.
I see.
And then so like specifically for weights and biases, I happen to have, because I love weights and biases so much, I made an action that does this. So what happens is I actually logged the commit SHA that is associated with the machine learning workflow, and two weights and biases. And then when the model is finished training, it takes that SHA and it pulls it from weights and biases. So that kind of becomes the input.
Okay.
And so that's one way of doing it. And then another thing I do is like when I deploy a model, so weights and biases puts a comment in my PR. It's a table of all the different runs and the run IDs from weights and biases. And then I just have a chat command. I say, /deploy run ID. And then in actions, I parse that command and I say, okay, like give me the run ID, and I pass it into another like action that then takes that run ID as an input, and then it goes out to weights and biases, downloads the model, and it pushes it to my serving infrastructure.
Well, Hamel, I didn't know you did that. Can we give that to other customers?
Yeah, I really would like to.
Dude,
I think it's super cool. Yeah, it's super cool. Like, I think it's something I'm really excited about, actually.
Nice. Well, you send me a link. I would love to play with it.
Yeah, yeah.
Sweet. So basically, your GitHub Actions kind of lets you build developer workflows, and you're using it to do essentially CI/CD for ML.
Yeah, so let me kind of paint a clearer picture.
Okay, yeah, totally.
And so imagine the scenario, like you may see it all the time. So you open a PR, you want to make a change to a model of some kind. Happens all the time. And you want a way to be able to see if this model is better than the baseline or whatever you might have in production. Now, how do people do that today? Even if you have something really cool like weights and biases, that's still a separate system than GitHub. And you might have to go out to weights and biases and copy and paste the link into the PR, say, hey, I ran this code in there. But that's kind of prone to error. Like that might be a stale run. You might have changed the code since then. You never know.
Yeah.
And it's all in different places. You want to go back to the PR, depending, that's like a manual process. It's not a good practice. So in machine learning, workflows can take a long time to run. It can take like, a day, a week, whatever it might be. But sometimes you might want to do a full run before you merge some code. And so with GitHub Actions, what you can do is you can say in your PR, I'm ready to test a full run of this model. And then you can issue a chat ops command and say run full test. And then your model runs on your infrastructure of your choice, logs to the experiment tracking system of your choice. And then it dumps metadata into the PR in form of comments and other things, where you can see all the results of the diagnostics of this model that you want. And then finally, you can decide to deploy this model or do anything else using another chat command and then deploy it. And so now you have this really rich record of everything in the PR that's associated with that PR. And it's getting closer to proper software engineering practices where you have like the test that's like automatically conducted from the PR itself, and you have all the documentation there. I've even talked to some weights and biases customers. What they do is they have Jupyter notebooks on the side, and they copy and paste those Jupyter notebooks into the PRs. And this is to avoid all that stuff, so it just happens automatically. So I hope that helps. That's kind of a
no. That was great. That was educational, and I think we should try to package up what you did and offer it to our customers. I think they would like it.
Yeah.
All right. Well, we've been talking for like half an hour, so we probably should wrap up with some final questions that we've been asking everybody and getting really interesting answers. So, what is one underrated aspect of machine learning that you think people should pay more attention to?
I actually think like one of the highest impact areas you can try to work on as a data scientist or a machine learning engineer is to build tools for other data scientists. And sometimes the tools they don't have to be sexy. So there's another thing that I built called Fast Pages, which helps people share information and write blogs, which is sounds really unsexy, and it really is very unsexy. But I think, that kind of stuff is very useful. So thinking of things that you can do to automate your own workflow and then share that and package that into tools, I think that's very underrated.
Nice. Well, from one tool maker to another, I have a lot of respect for that.
Yeah.
That's awesome. We'll put a link to Fast Pages. I think it's super cool. All right. Next question is, what's the biggest challenge of making machine learning actually work in the real world in your experience?
Yeah, I think that there is a gap between software engineering and machine learning and the kind of different disciplines that need to work together to a lot of times pull off a successful deployment of machine learning. And I think part of it is organizational, and part of it is tooling. I don't think tooling can get you all the way there. I think machine learning is a team sport and requires people from design, UX, of course, ML folks, infrastructure people, DevOps, all kinds of people to pull something off. And so I think that it can be a challenge to kind of get those people together in a lot of organizations to do what you want.
Have there been any particular dysfunctional patterns that you've seen over and over with that, or? miscommunications?
Oh yeah, yeah. I mean, I think the main pattern that I continue to see over and over again is, oh, my business, is in trouble. Let's sprinkle some data scientists on it. You don't just hire a data scientist to solve a machine learning problem. You need to think about it as a holistic product. And I think that pattern keeps repeating itself over and over again.
While you're still seeing that, reminds me of my first job.
Yeah, it may have not changed much, but I don't know. I mean, hopefully the industry is getting a little bit better.
All right. So final question is, if people want to learn more about what you're working on, get in touch with you, what's the best way for people to find you online?
Yeah, I mean, there's a lot of ways you could find me on Twitter. I have a website that I haven't updated in a while, but you can do that. You can just Google me. There's a lot of stuff.
Nice.
Yeah, it's
all right. We'll put a bunch of links for people to come use your tools.
Yeah,
Hamel,
cool.
thanks so much for chatting. This is really fun.
Yeah, thank you.
Appreciate it. Cheers.